So if this is Amsterdam, London, Paris, this is more or less where I live in Belgium. So, well, as Philippe said, I'm Mathias Verraes. I'm a consultant. I have a small business of helping companies do modeling and analysis and software quality and architecture, that sort of thing. I'm going to try to convince you of temporal modeling. What is it? Well, if you look at systems, human-made systems or natural systems, you can look at them as things. So if this is, well, systems, you can look at them as things, entities, objects, structures, or you could look at them as processes, as events happening over time. And that distinction is important because I think that they're both ways of looking at the world, right? None of them is right or wrong. But this way of looking at the world, the structural way of looking at the world, is, I think, too common in software. We're looking at our domains and the software we're building for them as state in a database that we do operations on. Whereas if you take the other side, temporal modeling, we can model it as events happening over time. And I think that's much more relevant and much more important for what we're doing, because most of the businesses that we work in, most of the domains, the interesting problems are in fact temporal problems, are in fact problems about how does something behave over time, right? So I'm going to try to convince you of that. Of course, this particular conference here, everybody has already been talking about events and event-driven architectures and event storming and event sourcing. So hopefully this will be an easier job. What I hope is that you will ask a lot of questions and interact a lot, because that helps me, figure out how to explain it to this particular audience. And that's why I don't have slides, because that allows me to sort of adapt to your questions. So let me maybe start with a simple example, where looking at the world as events over time can help you understand the system differently, or help understand problems differently. So this particular example, let's imagine we have a SaaS product where, a B2B product maybe, people can subscribe to it. And of course, sometimes people want to cancel their subscription. But sales came up with this idea that if people cancel their subscription, that's sort of a lost opportunity, right? Maybe they didn't really understand how to use our product. Maybe they didn't spend enough time with it. Maybe they thought it was too expensive, whatever. So sales would like an opportunity to actually resolve that situation. So they come up with this feature where when you cancel your subscription, you have 30 days where all your data is not deleted. We just keep it, and we allow you to sort of reconsider that. So, well, I guess by now you know how event storming works, so I'm not going to explain that in detail, but let's just write down the events that happen, right? And the first thing is just a subscription was canceled, right? So maybe, well, before that, there could be a command, somebody clicking a button saying, cancel my subscription. But so let's just start from this event, right? It's the trigger for the rest of the process. So when we look at systems in a temporal way, we now need to model the fact that something does not happen, right? So for the next 30 days, nothing happens at all, and then we should do something. How do you model the fact that nothing happened? Well, something happened. It's time. Time has passed. Time passing is an event as well, right? So we could model, we could just make that explicit. That's a DDD thing, right? Make the implicit explicit. So 30 days have passed, and then the next thing in reaction to that is the reconsideration period has expired. And then something, so this is all just reactive, right? Something listens to that. It's just an event listener, process manager, Saga, whatever you want to call it, that emits a new command. I'm using a different color for that, for clarity, that tells that mechanism to clean up the account. So work happens, all that data is deleted, and then just to make sure that we have a record of that, something emits a new event saying account was cleaned up. Let me just put that here. So now we have the basic flow. Of course, this is not the happy part, at least from the point of view of the salesperson. They would actually call themselves customer success person because they're trying to avoid that situation by helping the customer maybe use their product better and succeed with it. So we need to model the other case as well. Let's put that, well, let's move that a little bit. And so in the happy part, the customer does in fact reconsider, and then we can emit an event for that. So this is where the customer actually pushes that button. It's a command again, and as a reaction to that, we have an event that represents the fact that it has happened. Right? So cancellation was reconsidered. We have something missing now. Maybe can you see what's missing? It's well, it would be an obvious bug if you were programming this probably, but there is nothing here that says to not clean it up if the cancellation was reconsidered. Right? So we can express that with what I like to call a constraint. If you think about it, this is sort of the essence of what software does. The only thing that's missing here is queries, which we're not going to discuss, but you can model any software system, or any business software system at least, as queries are how a user gets information about the state of the system. Commands are how they affect the system, how they send instructions to the system. This is the intention that they have, the decisions that they made that they express to the system. Events as expressions of what has actually happened. And then these constraints as the things that govern all of this. They govern all of these processes, right? I call them constraints because you could call this a business rule, but a business rule is sort of a limiting name for it, I think, because there are things that aren't really business rules per se. For example, a physical constraint. If I want to sell a certain product, a physical product, I cannot send that product to you if I don't have that product in stock, right? That's a physical constraint of stock, right? So I wouldn't call that a business rule. If I were to model this in, well, I don't know what color this is, purple-ish or something. If I were to write down the rule, don't send a thing that you don't have, that's not a business rule. That's not somebody in the business who decided that that should be the rule. What they can decide is we can sell you the product that we don't have in stock. We sell it to you, and then we send it to you once we have it, or we'll try to find it, and then we send it to you. Or the business could decide, we will not sell you anything that we don't have in stock right now, because then we wouldn't be able to deliver it within 24 hours. Right? If you're as big as Amazon, that's probably not an issue, but for a smaller business, that would be a problem. So the business rules are about what a business decides. Physical constraints are where you have to make sure that you're not exceeding some stock or some scarce resource or something else that wouldn't be possible in the real world. So in general, I just call them constraints. I know that Alberto Brandolini has a different set of names. But I want to avoid calling something a policy because policies are a very specific thing in insurance, and I don't want to decide on where this goes up front. So I might be in some cases you might move this around and then decide that we're doing something first, and then we apply the constraint and try to do a compensating action. But in this case, of course, that would be rather silly because if we only have this constraint after the account was cleaned up, then it would be too late anyway. So let's go back to this process. So now, what we can model now is basically how this decision is being made. So what is constraint really? We tend to think of it as something that looks at the state of the system and uses that state to make a decision. In temporal modeling, so when we're not trying to see the world as structures, but when we're trying to see the world as events happening over time, we can still express that constraint as events over time by saying that instead of it depends on some state somewhere, we could say it depends on knowledge about things that have happened before. Right? So every constraint makes a decision based on past events. Right? We can draw that. We could say, only clean up this account if it was not reconsidered. What do we need to make that decision? That's information about the account. That would probably be something like an account ID. We're depending on that, perhaps. Actually here we already have that relationship, so maybe this one could be optional. And we depend on this event here, right? So we're always looking backwards in time. To make a decision, we're looking backwards in time about what has happened, and that's how we make our decision. You could say, well, this is a lot easier. We could just look at that state. But if you think about it, where does that state come from? Well, from there, of course. So these arrows here, well, you could draw it in the other way and say the state is a consequence of this event. So whether you draw it as this, the constraint makes its decision based on events that have happened in the past. You could draw it as it depends on a state, and that state is the consequence of something that has happened in the past. Right? You could see this in the same way that many people believe that your personality is the consequence of everything that has happened to you in your life. That's the same sort of idea. So what we're getting at here is that an entity, if you start thinking, or a value, or any kind of state, is just a consequence of events. So let's explore that idea a little bit. So the way I look at the world using temporal modeling is everything is a process consisting of events, and I go really far with that idea. A customer, for example, is a process. We think of that as an entity, but a customer is somebody who comes in, subscribes to your service, does some interactions with your service, maybe upgrades to premium, and maybe at some point cancels or quits. Right? That's a process over time. Right? We tend to think of that as an entity, but that entity only represents the current state of that customer. Right? Is that making sense so far? Yeah? Was that a question? Or? Oh, no, that's a thumbs up. OK, thanks. These events are actually a much more fundamental thing. We're used to this sort of structural modeling, right? We draw a bunch of objects, maybe, or entities, and they have relationships, and they have a name, maybe, and some state, and these relationships. And then sort of as the last stage, we start looking at behaviors on top of those entities, right? And then we might express those behaviors as events coming out of those entities. So we say the customer did this thing, that's an event. So here it's sort of in this structural modeling, we start from structures and state, and then we start layering on top of that how that system behaves. But if you think, as I said in the beginning, if you think about software, the reason for having that software is mostly that behavior. There is software that only exists to store data and to structure data. But those are not the very interesting systems, right? That's sort of maybe anything where it's just sort of data entry and storage and retrieval. Those kind of systems are probably best modeled like this, as structures. But I think that everything else is better modeled as behavior, because if you look at what is the point of this thing, It's being able to do these things over time and constraining them with the things that we care about, the business rules or the constraints, right? So this drawing, this model here, this concept, it's not just model in the code, right? It's not just a schema in the database. It's our conception of what these things are, what our system is about. I feel that's very limiting because it doesn't tell me anything about how that behaves, right? I'd have to start looking at those methods, but even those don't really tell me that much about when does this thing get added to that structure? How does it get removed? How many of them are there? Well, we have notations for that, which are 0 to many or 1 on 1 or these kinds of things. But even then, this drawing doesn't tell me if this structure is always initiated as a whole, or if this is built up over time. And if it's built up once over time, well, so it's built up over time and then it's stable, or it keeps evolving over time. This doesn't really tell me anything about that. Of course, well, this is a very empty drawing with no text on that, and of course you would know something by talking about the domain experts. But the understanding of how the domain works isn't really expressed in that, right? That's sort of a simplification that only looks at the consequences of the behavior and not at the behavior itself. And if you think about how domain experts tell us what they want and what they expect, it's stories, right? They say, this thing happened, and then I expected this thing to happen, but this other thing happened instead. Maybe that's a bug, maybe that's a change, a requirements change that they're interested in. That's how they tell us these stories. And then our brain is going, okay, so that's a customer entity and a one-on-one relationship with this thing and that thing. We're sort of translating it down into something that it is not, right? If you look at this tells me a lot more about what happened next. I'm specifically using this kind of language here even to be even closer to the language of how the domain people talk. They don't say subscription cancellation event, right? They say a subscription was canceled. That's how they tell the story. So, and we can take this quite far, actually. There is, so I said systems, we can see them as things or as behavior, as processes. There's even more to it. Here it's, entities and structures and things. It's ontology, right? It's what is it? And what we tend to do as programmers is start classifying things and categorizing things and finding hierarchies of things. We say, oh, but this is this type of customer and that type of customer. We start putting things in these sort of, even at the worst case, nested hierarchies of types and subtypes. And there's nothing wrong with that per se, but we're sort of doing that as an, automatically without even thinking about it. Whereas that may not be the thing that actually is relevant to this thing. And customer is still a very simple example, but if we look at it at behaviors, there's a bunch of things that temporal thinking can tell us. For example, being. How does this thing, this structure, remain the way it is? That is a being process. This is what, if you read Weinberg, Rethinking Systems Analysis and Design, he talks about the 3 B's, he calls it, 3 kinds of processes that happen here. So one is conserving the structure of something. The second is what we would call behavior. It's the things that the system does that are usually repeatable. We can have many customers subscribing and unsubscribing. They're often reversible. Well, not always, but there are things sort of the natural or the daily operation of a system. That's behavior. And then there's a third thing that is completely invisible here as well, which is the becoming. Becoming is the learning of the system. How does the system evolve into something else? It was this kind of structure, but a new requirement came in. How does that affect everything else? That's becoming. And if we take this example of customer again, I said a customer is a process. You might still feel like a customer is an entity, and my language sort of maybe suggests that, right? A customer, that specific customer. So in the domain, we might still have that concept of this entity. I call that a domain entity to make the distinction from an entity in code. Right? A domain entity is our concept of something with an identity, and an entity object maybe is a representation in code. But we're still sort of thinking of this customer right now as a thing, right? But even that is a business choice. That's a weird thing to wrap your head around. Seeing the customer as an entity is a business choice. But it's actually not that hard. Imagine you have a brick and mortar store, and somebody walks in and buys something. That's an event, right? We cannot deny that this fact has happened. And then the next day, the exact same person walks in, so there's identity there in the real world. This exact same person walks in and buys something. But when you're a brick and mortar store, you might not connect those two events together. You might just say, these are two customers. Today, a customer walked in and bought this thing. Tomorrow, a customer walks in and buys that thing. If there's no relation between those two events, there is no customer entity, or at least not a customer entity with a life cycle that is longer than one sale. Right? So that's a choice. Of course, in software, we will often choose to connect these two events and say, well, this is the same customer that we're tracking over time. Because, of course, it's very easy and cheap to track everything. So when somebody says a customer entity, that's already a choice of the business to track multiple sales using some common identifier, right? Some common identity. So even an entity, if you start thinking about it, is just a process. It's a life cycle. It's a series of events that we connect together by some identity. We could look at it different, and we could say each of these purchases, we connect them by the identity of the product type that they bought. So if people come in and buy all our stock of, I don't know, X, we could say, well, identifying individual X might be a bit too much, but let's say, well, it doesn't really matter. Let's say somebody comes in and buys an egg, and the next day somebody comes in and buys an egg. We could see that as a process, as an entity, as a life cycle that describes how these eggs all got sold. This process starts with maybe buying a box of, I don't know, 100 dozens of eggs, and then each of them getting sold over time, and then we decide that we look at this as a process. Or we could look at some of these events for the eggs, and some other events for, so if this is eggs and this is maybe milk cartons, and we look at some of these events and we connect them because they are the same customer or the same person, right? So that is always a choice. So what you get is that modeling, structural modeling, is always very opinionated. If you do, and I hope you're doing sort of some whiteboard modeling when you're designing software, that's the DDD approach. So when you are gathering with a group of people and you are modeling, a lot of what you're doing is sort of arguing or debating different opinions about how to structure stuff. In fact, I would recommend that you do that because there's always going to be different structures that have different trade-offs, right? If you just pick the first structure that comes to mind, that may not be the optimal one. But the problem with that is it's an opinion and it's based on what you value the most, right? So the structure you'll end up with is your particular choice of what to connect together and what to relate to each other. And then that depends on what kind of things you're interested in. Somebody might, so this model where we're tracking on product type, who's going to be interested in that? Probably the stock people, the inventory people. Whereas the model where we're tracking the concept of customer, that's maybe going to be the marketing or salespeople who are interested in that. So you have different opinions on what the essential entities are and what the derivations of those entities are, depending on how you're looking at the problem. But if you turn that inside out, right? If you start from the events, then all of this, so if you look at it as temporal modeling, we consider all these events first, and we don't consider them as an event that came out of an entity, but just an event that happened on its own. And then we can project those into entities, right? But then we have the choice. We can have different listeners, different projections. We have more optionality. We can have different things that each look at how does this subset of events make up this particular entity, and how does this other subset or subset that has maybe some of the same events and some different events make up this other structure, right? So we get a lot more freedom. So that's one of the sort of primary benefits, I think, of temporal modeling. So temporal modeling is not a methodology or technique. It's more of a mindset, right? It's sort of a way of looking at the world. And then things like event storming and event sourcing and even behavior-driven development and a lot of these things, BPMN, are sort of expressions or methodologies that help you do temporal modeling, right? But even there, I find that people are still very much attached to this idea of entities and state, right? I see a lot of supposed BDD, that is, when I have a state, given I have a state, when I do some action, then I have a state. To me, that is, well, first of all, that's not behavior-driven development to me. That is state transfer development or something. And it's easier to lie with something like that, because you can come up with states that don't actually exist, that aren't actually possible in that system, that you would never reach through a series of events that, or through a series of actual interactions with the system. So it doesn't really tell you what happens. It doesn't really tell you what the user is doing. Whereas in temporal modeling, you're going to look at that as given a series of events, when an action or a command, then I have some more events, one or more events as a consequence. Or even no event at all, right? Then nothing happened. That's also a possibility. For example, if you were to model idempotency, if I, let's say I unsubscribe, so I subscribed, etc. When I unsubscribe again, then nothing happens because, I was already unsubscribed. Or it could be then some exception, where an exception is really just an event that we didn't want, right? Is this making sense? Any questions? Oh, sorry.
So I don't know if you're gonna get there eventually, or like a checkpoint state at some point, instead of replaying all the events from the beginning every time. Do you think that like a certain specific state that's been...
Yeah, so is your question about what if we store all the events and then we want to know the state? Yes. So in event sourcing, that's kind of a solved problem. I'm not specifically talking about event sourcing here. I'm talking about the mindset of how to reason about our systems, how to draw our models, which you could then still use to draw an object-oriented system or an event sourcing system. Of course, an event sourcing system is then the system's design will look more like the model here, like the conceptual model. But so if you're doing event sourcing and you store all of these events, you can reproduce state, but if you have 1 billion events in your event store, reproducing that state would be very expensive, right? That's your question. I'm sorry?
For BDD also, because you have to replay.
Yes, but the practical solution to that is that you could still store intermediate state. So I could say, so if this symbol means the beginning of a process, right? I could say a customer signs up for the first time, buys a bunch of products, and eventually is promoted to premium customer. Because the constraint here, there would be something like this in the middle here that says, if you bought, I don't know, $1,000 worth of product, you're upgraded to premium. So this is one of those constraints that you could model it as the consequence of everything that has happened before. And your question is, if we have 1 billion of these and we need to recalculate that, that's a very expensive operation. But at every step, we could store that state, that intermediate state. So an event comes in, an event listener adds some values to some persisted state somewhere, and then incrementally changes that every time an event comes in. So that when we need that state, we don't need to start from scratch. We can just look at that persisted state. It's basically a cache, right? There's nothing special about it. But conceptually, we can still think of that as the consequence of all the events that happened before. But because we store the events, we're not even stuck to that one interpretation of it, right? That's one of those benefits that I'm trying to get at here, that here, if you only store, in a structural model, if you only store the latest state of that customer, you are already making a design choice of what kind of state to store, right? If, for example, you wanted some historic information, if you wanted to know how long it took, or what the average prices of the average size of a purchase was at some point in time, right? Not just now, not just the present state, but what was the average sale price in 2017, and what is it now if you want to compare that? We wouldn't have that data. If you do event sourcing, you have every change, and you can still project any kind of information that you want from that, even if you didn't think about storing that kind of information beforehand. So you get sort of time traveling for free, which is one of those other big benefits. If at some point you decide, well, we need auditing in this system, you have it for free because you already have a log of everything that happened. That is not arbitrary, right? Does it answer your question? Any other questions so far? I think the gentleman in the back.
So your constraint has to get events. Is there a specific aggregate it gets those from?
Well, aggregate is sort of a big discussion here. I'm having sort of an ongoing discussion with people to get rid of the word aggregate and find some better replacement for that. Felipe, could you pass the mic again?
Excuse me, unit of certainty.
Yes, you read Twitter. So, because aggregates has this association with structures, right? With an object graph, a composite of entities, which is how it's described in Eric Evans' book, because when it was written, there only was object-oriented programming. That was the dominant way of designing software. But an aggregate exists here as well. It's when, because an aggregate is really about the constraint, right? An aggregate is about, there's a set of closely connected constraints that we need certainty about. When we make that decision, we shouldn't be able to, for example, have two things that try to get that same last product that was in stock, and they both get it, but of course they can't both get it. So an aggregate solves that problem of, well, as I call it, units of certainty in a distributed system. But that's a topic for a complete talk, so I don't want to spend too much time on it. But at least remember this, that an aggregate is not an entity. An aggregate is not a set of entities. An aggregate is a set of constraints that are connected together and that we want to enforce with strong guarantees. So it's an architectural pattern. Entities are an object-oriented pattern, a domain modeling pattern where we represent things with a life cycle. And we can use entities to implement aggregates, or we can use streams of events to implement them and then have rules about that. But that's probably too vague because it's a short explanation. But let's get back to this, because I want to show how temporal modeling, with this simple example even, can help us solve problems. You've been staring at this whiteboard for a while now. Who has found the bug? There's another bug in there. Anybody? So what I do, one of my heuristics when I'm event storming, when I'm trying to come up with visualizations of the stories and the behaviors that the business wants, is to not just visualize one process, but many variations of them and interactions between processes. Because we're not just, we don't have one customer who subscribes once and unsubscribes once, and that's our entire business. We have hopefully thousands of customers and hopefully few of the unsubscribes, right? So how does that interact with each other? Well, let's put more time on this timeline, right? So this would probably be on subscription is canceled. Let's call that day 1. And then, well, before 30 days pass, let's just move all of this a little bit. I'll just put them here and then rebuild them. That will probably be the fastest. Refactoring is cheaper on a whiteboard than in real life, but I still find that when I'm event storming with people, they are still hesitant to move post-its around, even though that's the cheapest refactoring you can do. So don't be lazy when you're event storming. After that, everything becomes expensive. So let's say the subscription was canceled. Let's see. Then at let's say that this is day 15. The customer reconsiders. So we have a cancellation was reconsidered. And on day, I don't know if I have a command for that. Well, let's just have this here on day, let's say that this is day 20. They change their mind again, and they cancel again, right? And then on day 30, 30 days have passed. And let's see if I'm doing this right. So day 30, now the reconsideration period has expired. Only clean up if it was not reconsidered. Let's see, I feel like I'm doing it wrong. Wait, how is this happening? So here, let's see, right here it should not be cleaned up on day. So this is all still day 30. Let's maybe make that a little bit simpler like that. So even though the constraint is being enforced, if this is modeled, that's what I'm getting at. If this is modeled as looking at a state in a naive system, of course, in reality, this example is too simple for to be believable, maybe. But in reality, if in a situation like this, if you had modeled it as just a state, then it would say that it will look at the fact that it was cancelled. So let's say if, yeah, I'm sort of making a mess of this now. But if you have a state here that says, for example, it was cancelled because we only have the latest state and not the history and no understanding of the history, then it would still clean it up, right? So now on day 30, we're still at day 30 here. We have cleaned it up, even though what the customer expected was that they had, here, they had another, now I need to calculate this, they had another 20 days, right, before the actual, so this needs to go. This is the 30 days for the second cancellation. This is for the first one. And then the reconsideration period has expired, and we have that constraint again. So like this. So what the customer and the salesperson expected is that on day 50, right, the account is cleaned up. Wait, this is the wrong one. So, well, cleaned up. They expect that they have these 20 days in between to change their mind. Maybe the salesperson is on the phone with the customer, agrees not to cancel it, to reconsider it, and then they go look, but actually the account is now cleaned up earlier than they would have expected it, right? Is this making sense? Because I sort of explained it a bit messy. But what I'm trying to show is that not just the implementation. You might find this bug. Well, you might find this bug when it happens, which is late. But what I'm trying to show here is that if you start reasoning about behavior over time, you're going to start discovering things like race conditions much easier. In fact, a lot of bugs are race conditions, are where we didn't really understand how things would work when there's multiple things happening, or things happening at the same time, or happening in parallel, or these kinds of things. I've actually experienced with a client where the head of product, who was not a software engineer at all, who was not a technical person, but he was using event storming, and he was discovering race conditions in the system that the programmers didn't know about, that had never happened even. So he was predicting bugs in a sense by looking at what happens when this happens. So what I do when I'm event storming is a lot of this sort of moving things around. What if this happens first? What if this happens before that? What if this happens at the same time? What if there's 5 customers trying to do that, right? So that's sort of one example of how modeling behavior to understand behavior is very helpful. In a sense, a domain model, just like a model in science, right? What is a model in science? It's a set of abstractions that is good enough to help us make predictions about a phenomenon. In software, this should be the same thing. Our conceptual model of the domain. How does the domain work, right? What are the concepts in there, and how do they behave over time, and how do we want them to behave? And our system model, right? How does our system work? What does our system do given certain inputs? These models are theories of what it does. If those models are not aligned, then you have a system that you don't understand, right? In DDD, we're specifically trying to align these models. We're trying to have some affinity between the system model and what we call the domain model in the code, etc., and our conceptual model of how the domain works, right? A legacy system is a system where you don't have a good model, and you cannot easily predict how it will behave to certain inputs. I was talking here about being, behaving, becoming. So the learning of a system is when we change it, right? Temporal modeling, and we don't have time to get into it, but when I want to design a requirement change or a new feature, I model the system as is, and then I model that new input as a new set of events and etc. on that existing model, and I can sort of see how that change will affect other processes in the system. At least that's what I'm looking for. In the legacy system, that's very hard. That's why legacy, that's very expensive there, because our confidence, our model is insufficient, our confidence in our understanding of the system is very low. So when we try to make a change, we have to reverse engineer all the possible consequences of that change. We have to test it a lot. We have to do code reviews. We have to do a code freeze of a month and then deploy once a year and then spend another 2 months bug fixing because we didn't have a good understanding of that system, right? Of how it behaved. So that's why this is all very expensive. DDD, in a sense, or domain modeling in general, is a way to build these better understandings that actually speed us up, right? A good understanding of your system that is very close and similar to your understanding of your domain, and you have a good understanding, that's a competitive advantage. That's how you go faster. When people say, oh, DDD is nice, but it's, it's slow and it's theoretical and whatever, and it makes us do a lot of extra work. Yes, but that pays off in the long run because changes become easier, right? So that's the becoming in temporal modeling. So I hope this was helpful. I'm afraid we ran out of time already, but I'll be around, so if you have questions, please come and see me. Thank you so much for your time. Thank you.